And I will share my screen. Cool. So welcome everyone. Thanks for joining another TripleO deep dive. This time we're gonna talk about various things, but the common topic of all of them is gonna be containers, and we're gonna talk about a little bit about deployment, a little bit about upgrades, CI and quick start, and such things. So yeah, just to give this some sort of an introduction in terms of containers. I think many of you are probably already familiar with containers somehow. I also sent these links earlier on, but just to give it a brief introduction, running an app in a container is something between running it on bare metal host and running it in a VM. It gives quite a nice isolation while not having too much of a performance hit. And this is quite beneficial for TripleO because we keep adding more and more optional services, and they have all their own dependencies. So having a separated file systems per service is really beneficial for us in terms of being able to separate those services and their dependencies nicely. It also forces us to really think about and explicitly state what those services need to, for example, change or amend on the bare metal host. So it should put some order into the deployment, given how many services we run on a single server. So let's just dive straight into it. If you already are familiar a little bit with TripleO, how do you deploy a containerized overcloud? So it turns out it's actually quite easy. You will just run the normal OpenStack overcloud deploy command, give your environment files as you're used to, and add one more environment file, this Docker YAML file, and that's going to deploy you a containerized overcloud. So it's as easy as that. If you're using quick start, you can use this containers minimal config for quick start, which is actually what our OVB CI uses. So it keeps being tested, and it should be working because this is what CI runs. It's all in the docs. I will share the links for the slides afterwards. You can always walk through the links as you want. And the undercloud, if you want to deploy containerized undercloud, that's the command for this is a little bit more difficult. Let's just look briefly at the docs. It's currently for development purposes only. We are not we don't intend this to be for really like production deployments, having containerized undercloud in Pike. It's probably going to come later. So it's mainly useful if you want to develop a service and iterate on it fast. You can deploy the undercloud, which should be faster, and you can iterate faster. So there are these docs. This is the command that you would use to deploy containerized undercloud. Some prerequisites as well. I will not dive too deep into this particular thing. So let's look at the YAML files. I said that all you need to do is add this docker.yaml, and let's see what it does. It basically amends the resource registry of Heat in the sense that you deploy a Docker service on all the hosts, which by default it's mapped to none, like a no op. So here you enable it. We also have this node user data, which on compute node only it disables libvirt so that we can run it containerized. This should go away soon so that we can free up the node user data hook for custom use cases again. There's already a patch posted for this to disappear. And then a bunch of those services, like you can see here, they just switch the service variants from Puppet to Docker. So you're going to run those templates that deploy Dockerized services instead of the ones on bare metal. We have our custom post-deploy steps and post-upgrade steps, and we have a custom service munging file because we have a couple more entries in the service manifests compared to the old bare metal deployments. And then finally, we here override the compute services. I suppose this should be temporary as well, and when we have things finished, this should go away so that we don't override the services, but instead you use the services that you defined in your role files. There's HA work in progress coming. So if you want to deploy HA with containers, you would use this file in addition to the docker.yaml file. You can see it's pointing to Gerrit, so this is not yet merged. It's work in progress, but yeah, it's getting there. And there's also an environment file, just so you can see, which enables TLS with containers. This is something that Juan's been working on. So yeah, I personally don't know too much about this, but if you want, you can ask Juan. Just wanted to make sure that you know it exists. So yeah, container images. You can, if you deploy this way, as I've shown, then I mean this first command, then it's going to just fetch the images directly from Docker Hub. But if you want to sort of locally optimize things or play with your own images, you can use local registry on UNDERCLOUD, which we deploy by default, I think now. So if you want to just pull the default images from Docker Hub into your local registry, you can use this command on UNDERCLOUD. And then you would add one more environment file to your overcloud deployment with these parameters, so that you basically point the overcloud Docker to use your custom registry instead of fetching images from Docker Hub. And you also need this parameter, which, among other things, tells Docker, the way we use it, it tells Docker that it shouldn't try to connect to this registry via HTTPS and expect a valid certificate. So yeah. If you want, so yeah, let's talk about how we actually build those images, where do they come from, etc. So we use Kola images, which is like a OpenStack project aimed at supplying OpenStack container images and deploying them. So just to give a quick excursion, they have these Docker files for each container. You can see it has some Jinja elements, so it's sort of composed because they have the common things extracted so that they don't have to repeat them. So you can go looking for the Docker file sources of the containers we use in the Kola project. And one more interesting thing is here, and that's this extend start script, which for the Kola images solves, it works like essentially the entry point. So unless you provide your custom command to run the container with, it's going to by default go into this extend start script. So if you're not sure what it does or it's doing something you don't expect, it's good to just go to the Kola repo and look up this extend start script so that you can see what the container does if you're hitting some trouble. And so yeah, I said we use the Cola images, but we have our own customizations for them, mostly just installing more packages there. Basically, for example, we need Puppet in those images because we run Puppet in the containers. Yeah, then per container specific like Galera overrides, etc. Currently, we also need custom repo with bleeding edge pacemaker like software pieces. This should go away as soon as the things that we need land in CentOS. So this is the override file. And if you want to build the images manually yourself on your node, you can use the Cola build tool. You will again point it to the local registry on the UNDERCLOUD and give it the necessary parameters, how you want to build the images and how to name them and tag them. And you need to also point the tool, the Cola build tool, to the template override file that we use in TripleO, that you get the extra packages, etc. This is all documented in our docs on TripleO.org. So basically all I've been talking about, from getting the images, building them, specifying that the overcloud should use your UNDERCLOUD registry, and then deploying the overcloud or deploying it with Quick Start. You can always find it in the docs. If not, if there's something missing in the docs, feel free to file a bug. And then a fresh new thing is the fact that we started building the images in RDO repository. I don't think we switched to it by default upstream yet, but I expect that we will do this at some point, because the intention is that with every repository promotion, as late as past CI, we would, like of the RPMs, we would get a set of container images with this as well, so that we don't have to build them manually. So far, we've been building the images manually, and it would be better to just have this done in CI when the RPMs are good. So yeah, this is another link that you can explore later. Right, that's from the usage point of view, sort of. We can now dive into a code a little bit. I'll just check if there's some unanswered questions, because I can see that there's been some chat. Okay, doesn't look unanswered. Okay. So next, the service template. Let's take a look at Nova API, because that's a little bit more complex one. So this is a heat template, some parameters in the beginning, and then resources. This is a thing that we instantiate for all container templates. Let's just switch to it right away, so that this is just a set of just a list of container volumes which we want to mount into all containers that we start. So we basically take care that you get the etc hosts from the bare metal hosts, the time information. We also mount the Puppet directory, because yeah, we use this bootstrap host exec tool, and I think it relies on Hera data to tell which node is the bootstrap node, and the purpose of this tool is to run something just once in the deployment and not on every node. So it needs the data, the Hera data from etc Puppet. Then we mount in basically PKI certs, so that the containers trusts the same thing as the bare metal host, syslog socket, and known hosts. I think this was important mainly for Nova because it needs to SSH somewhere. I think during migration, probably, but yeah, I'm not sure. So this is something that we mount in all containers as volumes, instantiated here and then used later on. We also instantiate the Puppet variant of the service because we inherit mainly the here data. That's the most important thing. We inherit more from the Puppet services, but mainly the here data is the most important thing, as we would not want to repeat all of this here. So you can actually see it used here with the config settings. That's the here data, and we merge the here data that comes from the Puppet service with some additional overrides from specific for the Docker service. Yeah, I skipped the service name. That's just the metadata to know which services are deployed on a host or in the deployment in general. And again, we just get it directly from the Puppet service. Here, the step config is actually the Puppet code. So you can again see that we pull it from the Puppet variant of the service, and we add our custom thing here to make sure that the Nova cell resource is a no-op and doesn't try to execute here, because we set up the cells in a different way via containers later on. It's going to be visible. Service config settings, again, directly taken from Puppet. The difference between config settings and service config settings is that service config settings allow you to sort of export here data from one service to be used with deployment of another service. This is particularly useful, for example, if you want to initialize Keystone endpoints. So services export their endpoints, and then the Keystone service creates them all, because it is sure that it can locally talk to a Keystone API. These are the sort of normal things that we've already had before, and here are the Docker specific config parts. The Puppet config section specifies how do we run Puppet in a container that generates config data for the containerized service, and later on we mount this config data into the service. So basically you specify a config volume here, which just defines a name of a, I would say, rooted directory where you generate the configs. It's going to be visible later on somewhere here. So this Nova is actually this Nova. It has to match. So you will basically generate the config files in a root and then mount them into the container in the root. So that's the config volume. Then Puppet tags. By default, we run Puppet in the container with just tags that make it generate files, config files, and edit files, but not do anything else, like, for example, the Keystone endpoint creation, etc. So we just run the Puppet in this particular container. We just run the Puppet in a way that it generates file, but it doesn't do anything else. So this is why the Puppet tags are what they can be used for. By default, they have just the file things, and here we add a Nova config, because this is also tag that will make Puppet generate just the config, but it's not something common, so it's not the default in the Docker Puppet hook, which we will explore a little bit later. Step config, it's the Puppet code which we defined here, and config image is the Docker image, which we will just we just get here from the stack parameters by default, it's Nova config image here. It's the CentOS binary Nova base image. Then comes Cola config, which like a special section that we use for creating config files for the Cola containers. And the format of this is really specific to the Cola project, but briefly, this is how you tell Cola what command it should run in the container, and this is like a little tool in Cola that allows you to change the ownership of this path in the container recursively. So it's like a Cola feature, because this is fairly common to do with containers, given that the user IDs from the host can be different than the user IDs in the container. So next up is the Docker config section, which actually defines the containers that we are starting in each step. So we have, similarly as we've had with Puppet before, we have these global big sort of steps that are global across all nodes. So in practice, this means that the step 2 has to be finished on all nodes before step 3 is started on any node. And yeah, I'll also just talking about ordering, I'll jump to this, which is a micro ordering within the global step. And this start order only works within a single node. So you can use it to further orchestrate between these containers, like this DB sync has to run before this map cell container, because this one has a greater start order and they are both detached false, which means that the hook that we, or the tool Ponch that we use to run containers will not just start this container and then go starting another containers, but it will wait for this container to finish before it does anything else. So with the start order and detach false, you can actually do a micro orchestration of containers on a single host within one step. So I skipped image. That's again just a reference, reference to the Docker image. We use host mode for majority of our containers, definitely for the containers that run services. So they get access to the network interfaces on the host directly. And yeah, you can tell it things like which user to run the process as, and what volumes it should use. So here we mount the common volumes for all containers that we've seen earlier, and we add the Cola config file, the sort of rooted config data, and we also mount a like a specific directory for container logs. We put all the logs, all the old school traditional logs under varlog containers. And here we define a command which should run in this container, which means it's not going to use the extend start script from Cola, which we've seen earlier in the Cola definitions, but it's going to run this command directly. And yeah, there's more of these containers here, which basically do sort of like initialization tasks or maintenance tasks. They all have this start order and they all have detach false, so that they run in succession. And then here in step 4 comes the actual Nova API container. And here you can see it doesn't have detach false. That's of course important because you can only use detach false with containers that you expect to finish soon. Obviously, if it's a container like a service, then it would, if it had detach false, it would block the deployment. And yeah, one thing to notice again is that we unlike here where we provided command, here we don't have a command, so it's going to run the Cola entry point, and we need to provide this environment variable for Cola to work correctly. And then here in step 5 is another task with detach false. This host prep tasks is thing that we like a set of Ansible tasks that we run on the hosts where this service is going to be deployed before we run anything else. So before we run Puppet, before we start those containers via those steps, we always run these host prep tasks. And yeah, quite often we use them to create this varlog containers directory specific for the particular service. And then upgrade tasks. I'm going to talk about upgrades later a bit more, but in general, basically we just use the upgrade tasks to stop the services on bare metal, and then we let the normal deployment workflow to start and configure the containers as we would do on fresh deployment. So that's how upgrades currently work. Okay, so that's the service templates and the common volumes. Okay, I see Martin is doing a good job of answering questions, which is great. If you want me to stop and go into something like answering some question or so, please just tell me, because I'm probably not going to keep up with the chat, so that we can progress. So now, yeah, I'll just have a sip. Cool. So let's talk about what is happening on the node when we deploy with containers. So first, we run this host prep deployment. I don't think we have time to visit all the links. It's just pointing to TripleO heat templates place where this is defined. Quite a lot of code. You can go through this later if you're interested, but I'm probably just gonna go through the high level here. So we run the host prep deployment, which runs just once on each host, and it consists of the host prep tasks that we've seen earlier in the Nova service template, and there are also some internal TripleO tasks which we've previously done more with like heat resources and bash scripts and stuff, but quite recently we have converted them to Ansible tasks because it helps us with rolling updates. So this is a thing that runs just once on each host, and then we have deployment steps, which is several steps. I think it's 5 or 6 steps that loop over again an Ansible playbook, and each of those steps goes like this. The first thing that we do is we create the HERA data for that step, and we run the traditional Puppet step on the bare metal host, the same Puppet configuration mechanism that we've been using before. Then if we're in the first step, we use the HERA data generated from here, and we run the Puppet in containers, which generates the config files for the containers which we start later. That's the Puppet with the limiting tags that limits Puppet just for creating config files, as I've talked about earlier. And once we have the config files, we can start launching the containers. So then we do first step of the containers deployment, and then we also have the option, not every service uses this, but we have the option of using something which we call Puppet tasks, containerized. which it only runs on Bootstrap hosts, so it happens like once per deployment or once per role. Now I'm not sure. I'll have to check this later, but essentially this is for running things that Puppet has been doing very well previously with the bare metal deployments, like creating keystone endpoints, for example. I'll have a link for this later. So yeah, we didn't want to write new scripts or for creating keystone endpoints, so we utilized Puppet for this, and it runs in a container in a very similar way as this configuration step, but it uses the same hook. It just has a little bit different configuration. We'll see this in detail a bit later. So yeah, that's like one step, and then you go again. So you go to step 2, and it runs step 2 on the host, Puppet on the host. Not this, because this is only in step 1. And then it runs step 2 of the containers deployment, step 2 of the containerized Puppet tasks. And you go like this until step 5, I think, and then it's done. Your OpenStack is deployed. So yeah, let's look just briefly at some code that does this. This Docker Puppet.py hook is what we use for running Puppet in containers, both the Puppet that generates config files and the Puppet that runs the one-time tasks like keystone initialization. So it's like quite a bigger script, but an interesting place is right here, which shows quite in detail how we actually run the Puppet inside Docker container. The important things here are the Puppet tags, as I've talked about earlier, and yeah, you can pass it a step. And another important thing is that we actually mount the Puppet directory from host, so that we get the hero data and also the Puppet modules, we mount them from host. Right, this has to be read-write, because as we've seen before, this is where the files are generated. That's the truth, as I called it earlier. Yeah, we put the mount the logs, and we get the CAs as well. Right, so this is one important thing, and then the other important thing which I wanted to show is somewhere here. This is the Puppet tags. We've already hinted at a few times. By default, when running Puppet in container, we only use these, as these are the main tags that are used, that basically are going to limit Puppet to only work with files. And then if you want the container to do something more, you can provide your own Puppet tags, and they get appended to this list. So you can actually make Puppet do more in the container if you want to. And an example of this is this thing is just what we've just seen. And an example of this is how we initialize Keystone, as I've already said. So here you can see that we expand the default Puppet tags with additional ones, which are going to be calling Keystone to create endpoints and roles and services and tenants. So this is how we sort of utilized bits of the old Puppet functionality in our containerized deployment. And then one thing that I should also mention is Ponch, which is a library which starts the containers which don't run Puppet. It's like the normal service containers and the one-time tasks containers that we've seen in the Nova manifest. And so this, it's idempotent tool which gets a config file describing the containers that it should run. It figures out whether they are already running and whether it needs to start something. Probably I don't think we have time to dive deep into this, and I would also probably not be able to present it very well. But yeah, you can, for example, see the detach flag here that we've seen earlier. So this is like the internals of what we use to start containers. With regards to networking, which has also been one of the questions that I got asked on the agenda, how to debug networking with containers. Basically, we use the host networking mode for all our services, which means that they have direct access to the host network interfaces, and from networking point of view, the services run as if they were not containerized. So if you want to do some debugging or utilize our original network isolation features, from that point of view, it's going to be the same as using non-containerized deployment. Now let's look at upgrades briefly. It's again not too difficult to upgrade. You provide the same docker.yaml file that you provide with a fresh deployment. You also provide this major upgrade file, which utilizes the same mechanism. I have it on the next slide how this works. Utilizes the same major upgrade mechanisms that we've had previously with composable services and composable roles. And you also need to provide the upgrade init command with correct repositories so that your deployment switches to correct repositories on the bare metal host. Because we still, even though we go to containers, we still run the upgrade on a bare metal host as well. So normal yum update and all the stuff that we've been doing previously. Currently, we have implemented well, just quote unquote, just the main step of the upgrades. If you want to separate the compute node upgrades from the main step and do converge, etc., that's still waiting to be done. So, yeah, as I said, we do the upgrades the same way as we've been doing them from a workflow point of view. We do them the same way as we've been doing them previously. So we run those upgrade tasks, which we've seen also in the Nova API template. Those Ansible tasks get collected from all services and they get run on the host. And then we run the deployment workflow like on a fresh deployment. So the containers get configured and started. Yeah, that's probably not worth to go through the code again, given the time, but yeah, you can go through it later if you want. So we use the same workflow for upgrades, but we don't use the same upgrade tasks as the Puppet services have. We have our custom upgrade tasks. Okay, and then I think another big topic that people wanted to get some information about was how to debug containerized deployments. So if you're on the host where containers run, like the overcloud controller, for example, you can run this docker ps-a to list all the containers that are running there or that already failed for some reason. So you will see them all. If you want to see the sort of what should be the main logs in a containerized world, you can do docker logs and ID or name of the container, and that's going to give you the standard out and standard error of the main process that's running in the container. And ideally, it's considered a good practice in containerized world to use standard output and error to write all the necessary information that you need to debug the service. But yeah, given that we are just switching from services that use the old school logging, we also have this varlog containers directory on the host, which we've talked about before, which all the service containers mount in and they write their original logs into that directory, so you can also get to those logs directly from the host. If the logs are not enough for what you need to debug, then the workflow you're going to do next sort of depends whether the container is running or whether it stopped and it doesn't start again for some reason. So if it's running, you can run docker exec, then say that you want to attach your TTY to the new process. You give it a container name and what you want to run, and this is basically going to give you a bash shell inside the container, and you can look at all the files that are there and inspect the processes, etc. If the container is stopped or failed, this will not work. So what you need to do is, well, basically at this point, the container doesn't have any processes. It's just a bunch of files. It's a separate file system tree from your host. So what you can do is Docker export, which is going to give you a tar file of the container file system. And you can either use that tar file like for something else, or you can just directly pipe it into tar and extract it somewhere and look at the files there. So that's how would you debug a stopped container. And if you needed some details about the container or image, it works on both. You can run docker inspect, and it gives you some interesting information about the container, like what volumes it got mounted from the host, what was the command that was used to start the container, etc. And yeah, again, a link to our docs on TripleO.org. If you, just very briefly, if you want some other tips how to inspect Docker, here's how quick start collect logs, so you can look at the images, volumes, get some stats and information from the Docker daemon directly, etc. Copy files from within the containers, etc. Now, another thing that's going to be useful is if you have a patch that somehow affects containers and it fails in the CI and you want to debug what went wrong, essentially go through the CI logs. So you should probably always start with the console.html file, which contains the main critical path through the CI job, and that's where you usually find the first hints of what went wrong. Then where you're going to go next looking for logs, it actually differs between the OVB and the jobs running on OVB Cloud and jobs running on OpenStack Infra Node Pool. For Node Pool, you're going to go to /logs and the name of the machine, where the name of the machine is either UNDERCLOUD or subnode 2. I think we have jobs which have more subnodes, but most of the jobs that we have are just with subnode 2 here. So that's like the root directory of the logs for those virtual machines. On OVB, it's /logs/OOQ and then a machine name, and the machines are named UNDERCLOUD and OverCloud controller 0, OverCloud compute 0, etc. So if you're debugging logs from Quick Start, like from jobs that are run using Quick Start, the very useful directory where you want to look usually is in the UNDERCLOUD node. Under Home Jenkins, you're going to find a bunch of scripts that Quick Start generated, and also log files of what output the scripts generated when Quick Start was executing them. So that's a really, really helpful place to go looking, because it's going to contain the deploy logs, upgrade logs, etc. Often from looking at this, it's already apparent what happened. If not, then you can still dive deeper and look at varlog messages in the particular virtual machine, either UNDERCLOUD or OverCloud. You can also look at host info. There's quite interesting things like what services listened on what ports. I think there's also a list of RPMs installed. There's quite a lot of things in the host info.txt, so that's a useful one. And yeah, some specifically for containers, you can look at the varlog containers directory, which contains further subdirectories, as we've talked about before. You can look at varlog config data, which is a copy of the trooted generated etc. In varlog extra, there are some other interesting files which are unrelated to containers, but in varlog extra docker, it's all about containers. And there's an all info script, something like host info, I mentioned earlier, but specifically for Docker. And then each Docker container that was running on the machine has a separate directory under varlog extra Docker containers. And you can find quite a lot of info there as well. Yeah. So if you want to figure out how CI is doing in general, maybe if it's broken in general and not only on your patch, here are 2 quick links. I will not go through them because I will not go through them in detail because we don't have time, but here you can get like a CI status of how the jobs are doing, and here is even like charts and statistics. So it's something to go through later. Right. With regards to CI implementation, the newest Quick Start CI uses so-called feature sets, and it has an interesting matrix of what various jobs deploy. It's grown quite a bit over the last months. So this is where you can, like, if you're wondering what a feature set does, this is where you can find a quick info about it. And yeah, let's look at least these 2 feature sets a little bit in more detail, because this is the one that we run on Nodepool, and it does containerized overcloud deployment. And you can see that pretty much all that you need to deploy containerized overcloud is to set this variable to true with Quick Start, and then we also give it this specific composable scenario, which differs from the default one only in the fact that it doesn't currently deploy pacemaker, because we don't have HA in containers just yet. So yeah, when we get HA going, then we're going to switch to the normal multi-node composable scenario here, and we're just going to delete this completely. Then for the upgrade, it's a little bit more complex, but not too much. You start with containerized overcloud switched off, because we're doing Okata to Pike upgrades right now, so we want to start on non-containerized and upgrade to containerized. So here we set that we want to upgrade to containerized, and we have a special upgrade script for the overcloud upgrade role. I have a link to it later in the slides. Also setting up the TripleO CI master repos, both on UNDERCLOUD and overcloud. And yeah, we don't upgrade the UNDERCLOUD in this job because it's what we call a mixed upgrade, which means we deploy UNDERCLOUD, which is already the master version. And then on this master UNDERCLOUD, we deploy Okata overcloud with Okata templates and Okata packages, and then we upgrade the overcloud only to Pike and make it containerized. Okay, there are other feature sets for containerized upgrade scenarios. We have these scenarios that test various services, optional services, which didn't get into the main jobs. So we have scenarios for those, also for deployment. And yeah, I already mentioned that we have the specific composable scenario files, which don't have HA for now. And yeah, there's one more interesting thing in the TripleO CI repo, and that is our support for mixed upgrades. Basically, what we do is we look at the feature set file which we're using for this particular CI job. We look into it via a bash function, whether it's a mixed upgrade, and if it is, we look at what the stable release is currently for this job, and we set the upgrade release for a previous release from the stable release. Again, using a utility bash function. You get, like, if you want, you can dig through the TripleO CI repos and find the definitions for these to see more details about how we support mixed upgrade in the CI. So what I talked about before were those node pool jobs and node pool overcloud jobs, to be precise. But we also have one job on the OVB cloud. It uses the original CI script mechanisms to trigger it, but it deploys using quick start, and it deploys using the containers minimal.yaml quick start config that we mentioned in the very beginning of this deep dive. And then we also have a containerized undercloud job, which checks the containerized undercloud sort of development setup that I mentioned earlier. And it uses one more interesting thing. TripleO.sh has a support for deploying containerized undercloud. So if you're trying to deploy containerized undercloud and it's not working out for you for some reason, it's quite a good idea to go look at TripleO.sh how it deploys containerized undercloud, because that's what CI does, and that's what should be working. You can see the containerized undercloud deploy command here that we've seen earlier in the TripleO.org documentation. So if something's not working, this is a good place to go look. Right, here are just a couple of brief links into Quick Start to show that it's really not doing much special. This is the overcloud image upload file that image upload command that I mentioned earlier. Quick Start can also wipe Docker for you if you want. And then it uses this container's default parameters file, which is here, which is pretty much what we've seen in the documentation earlier as well, except it's a Jinja template in Quick Start, and it gets the generated IPs and namespace from Quick Start variables, but otherwise it's exactly the same. And yeah, Quick Start composes its arguments that it passes to overcloud deploy command from like bits and pieces that are defined here in this file. And here's the one that sets the container args part. I think we're getting rid of this one, and it's not really necessary. So what you should really be deploying with are Docker and the parameters which set the registry path. And here is the upgrade parts of what's in Quick Start. This is the file that sets repositories on the overcloud. Currently, this is what you need to sort of provide manually or via Quick Start. It's just thing that fetches DeLorean deps, DeLorean, and DeLorean current. It's the usual set of repos that we use for all CI jobs in the CI. And this is the script that defines how upgrade is done in CI. So again, if you're trying upgrade to containerized overcloud and something's not working for you, it's a good idea to look at how Quick Start does it, because that's what the CI does. And again, you can see that there's the overcloud deploy with Docker and major upgrade steps, and the file that points to the container repository, and the file that sets the bare metal DeLorean repos. And that's pretty much it. So yeah, that's how we upgrade in CI. Pretty much the same thing that I've talked about earlier. And yeah, I think that's it. Had to rush it a little bit to make it in time, but I think we went through the main things. So do you have some more questions before we wrap up? Okay, thanks for the kind words in the chat. Yeah, it was a lot of stuff. So yeah, if you want to revisit something, the slides are available. Okay, so I guess no questions. So thanks a lot, and I will stop the recording now.